The atmosphere. It's what lets us live and breathe on our tiny home planet. We wouldn't be alive without it, but how was it created? Was it formed in the Big Bang along with Earth's early surface? Did an almighty being snap his fingers and it just appeared? Not exactly, or at least probably not. Billions of years ago, 4.6-ish to be exact, Earth was newly formed and made up of mostly molten materials that cooled on the surface to form volcanoes. These volcanoes were filled with raw materials that were steamed out into the air through a process called volcanic outgassing. The majority of this steam was made up of water vapor, carbon dioxide, nitrogen, and sulfur. Notice how oxygen wasn't on the list of gases created in volcanic outgassing? This is because oxygen wasn't pumped out of a volcano like the rest of our gases. Instead, it was created through the process of photodissociation. This is where water vapor and carbon dioxide molecules are split, leaving oxygen molecules available to combine to form O2, oxygen. Photodissociation allowed for the creation of the ozone in the stratosphere. Speaking of the stratosphere, let's talk about the layers of the atmosphere. The atmosphere as we know it today is split into 5 layers based on the temperature structure between and inside of them. The first layer, and the one closest to the Earth's surface, is called the troposphere. It extends up to 10 kilometers, that's 8 miles for us Americans, and is where all of the weather occurs. Rain, snow, sleet, fog, or mist, it's all in the troposphere. As we rise through this layer, the temperature begins to decrease at the lapse rate of 4 degrees Fahrenheit for every 1,000 feet until we reach the next layer of the atmosphere, the stratosphere. The stratosphere, as previously stated, is where the ozone layer is located. The ozone layer is a gaseous layer that helps to filter out UV radiation and keeps most of these rays from reaching Earth's surface, lessening the intensity of the sun and preventing harmful radiation from soaking into the Earth and us. Think of the ozone layer as Earth's natural sunscreen, shielding us from the worst sunburn ever. As we travel up this layer, temperatures increase due to the heat that is released while the ozone layer does its work. Above the stratosphere is the mesosphere. Gases, including oxygen molecules, become thick, so thick that they help to slow down most meteors that reach the surface of the layer. Here, they burn up, leaving us with a shooting star. Farther up is the thermosphere, the first layer of the upper atmosphere. This is the layer where the aurora borealis is made and where space shuttles fly. As a result of incoming ultraviolet radiation from the sun being absorbed by the molecules in this layer, there is a large increase in temperature from as low as negative 184 degrees Fahrenheit to upwards of 3,600. The final and outermost layer of the atmosphere is called the exosphere. This is where atoms and molecules escape into the depths of space and where satellites orbit the Earth.